Okay, so I asked you to do some of these questions for homework today. They're review from grade 11, and most of you were actually pretty good at force questions in grade 11. But for some of you, it might be a while. So let's take a look at the first one. It says, a boy pulls with a horizontal force of 50 newtons on a 300 Newton wagon. If the coefficient of kinetic friction is 0.1, what is the acceleration of the wagon and how far does it go in 2 seconds? It starts from rest. Okay, so if you remember, the first step on these questions is draw the free body diagram with all the forces acting on it. So usually we just draw a box and then we put in the forces. So there's always gravity, Fg, acting down, and there's always the normal force, Fn, acting up. And it says the boy pulls with a horizontal force, so parallel to the surface, and that's the force of the buoy. And I think Mr. Smith used to call that Fa. I usually just call it F. And we're given that this is 50 newtons. Now it says the wagon weighs 300 newtons. That's not the mass of the wagon. The weight is the Fg. So this is 300 newtons. But you can get the mass of the wagon from that because Fg is just equal to mg. So you can use that 300 newtons to get the mass of the wagon. Then the question says coefficient of friction, kinetic friction, is 0.1. So that tells us there's friction. And so if the boy is pulling the wagon this way, then friction must be acting backward. Okay, so there's my free body diagram with all of my forces. And now what you do are the 3 steps that we always do. You do the sum of the forces in the x direction. So remember from grade 11, F net equals ma. Okay, so you can do the F net in the y direction, and usually instead of writing F net y, because it's then like a whole sentence of subscripts, I usually use the sigma symbol that you've learned in math. So the sum of the forces in the y. These two things are exactly the same. I just find it easier to write sigma than F net is equal to ma. So you're going to do the sum of the forces in the y direction. So you have the Fn going up and the Fg going down. So I'd call up positive. So it would be Fn minus Fg because that's going down. And this thing isn't moving in the y direction, so this goes to 0. So Fn minus Fg must equal 0. That means Fn must equal Fg. And we were given Fg. So Fn equals Fg equals 300 newtons. Then, because you were given the coefficient of friction, from Fn and the coefficient of friction, you can use the Fun equation to find what friction is. Okay, so once you get your friction, then the third, so remember I said there were 3 things: sum of the forces in the y, friction, and then sum of the forces in the x. And that also has to equal max. So in the x direction, you have the force you're pulling with going one way, you have friction acting backward, and that's equal to max. And the question is asking you for the a. So you've just found friction up here. They give you the f, so solve for a. All right? So it's usually always these 3 equations. The order sometimes changes. Usually always start with the sum of the forces in the y direction to get Fn. Then whether you do friction next or the sum of the forces in the x depends on what you're given and what you're asked for. If you're given mu and asked for a, then do friction first, and then the sum of the forces in the x second. If you're given a and asked for mu, then you would do this one first and the sum of the forces, or the friction one second. Okay, so it depends on what you're given. The second part of question 1 wants to know how far did the wagon move in 2 seconds if it started from rest. So that's just kinematics, right? So you'll have found your a. Starts from rest is vi, and that's 0. And it says how far did it move in 2 seconds. So once you get your A, then you can find delta D with the kinematics equation. Okay, so the questions are all like that. Just be careful on number 2. On number 2, you're hitting a hockey puck. Okay, and so it says a hockey puck is given an initial velocity. So when we join the hockey puck, it's moving 20 meters per second. So someone has already given it that velocity. They're not following it down the ice, pushing forward on it anymore. It's sliding on its own down the ice. So the only force acting in the x direction is going to be friction acting backward, which is what's going to slow it down. It will still have Fg on it. It will still have Fn on it. People always get messed up on this one because they try to put a forward force on it. But that forward force would only be there if you had your stick on the ice and pushing it forward as it's moving down the ice, and you don't. You gave it this velocity as you sent it on its way. So the only force is the backward frictional force. Okay? And so the first 4 are like this. You do have to use some kinematics in here, but that's okay. You can handle that, right? So if you're given a distance and a time or whatever, you might have to find the A before going on, or after you get the A, you might need to find the delta D. Okay? So give them a try. If you have any issues, post in the group, and then I'll tell you some more things. Okay? Thanks.